before we get to the worksheet 5A to D, I want to give you an example and then follow in the demonstration of buckling and crossing and how we define a column is short and long columns. So let's work on an example. And the question is very simple. Can we support a 50-ton tank on an A36? By now you know what the A36 steel. If not, go to Appendix B of the books to find out the mechanical properties of this material bar. So can we support a 50-ton tank on a A36 steel bar? And let's give geometry here with the length for the bar. In this case, let's give that here 2 feet length and 2-inch diameter. So with that, we go to, if you recall, A36 steel, we have the, go to the Appendix B, A36 steel with SI unit. The yield strength is 36 KSI, and see there. So from that, go here, we have to check for both scenario. The first one is failure due to crossings. So we have to check the first scenario is failure due to crossing. And then we also have to check failure due to buckling. So for failure due to crossing, we let the failure is due to yielding. So let the P yield is equal to P failure. In that case, so from that, as you can see, the sigma for the steel, A36 steel, the sigma yield equal to 36 KSI. If you recall that here, Appendix B. So from that, we can have the load, maximum load for failure. In this case, yield, as you can see, sigma equal to P over A. So now we want to find out the load when the steel bar start yielding. In this case, it will get the maximum yield stress and then time the areas, and it equal to 36 KSI time the areas of 2 inches diameter. So you have it pi d square over 4, right? 2 square over 4. And from that, we will get 113 kips. So from that, we can see we need GC basically evaluate the performance. So we do the analysis whether the actual less than the allowable. So in that case, as you can see, the P actual equal to 50 ton. And we have to convert that to kips. And if you know 1 ton equal to 2 kips, so it will be 50 ton times 2 kips for 1 ton. So total we have it 100 kips. So the actual is 100 kips. The failure 130 kips. So as you can see, it's okay, right? So as you can see now, P actual less than P allowable. So let's assume the factor of safety equal to 1 in this case, so assume it be failure 113. So from that you have it 100 kips less than or equal to the P allowable or failure in this case, because we assume factor of safety equal to assume factor of safety equal to 1. So from that it equal to 113 kips. So with that we say okay. So basically the bar is not crossing. Now we have to check whether the bar is buckled. So the next check is failure due buckling by buckling. And for the failure by buckling, we have to apply the load from Euler or critical load, and that is in this case the failure due to buckling, so it equal to the failure level P failure due to buckling. And as you already know, the P Euler equal to pi square EI over KL square. And let's model, and I will demonstrate in the next few minutes, but with the yeast water tank, let's model the column here. In that case, the bar, and let's assume it fixed, and then the tank on top, the water tank, right? And in this case, the tank P equal to 50 ton, or it also equal to 50 ton is equal to 100 kips, as you see there. And that if, as you can see here, is fixed, and that here free to move. I'll show you the demos later on. That free. So with the effect of end condition, we can see that the K go up here. The K in this fixed one end and free at one end. The K equal to 2, or the effective length equal to 2L. So from that we can apply the K equal to 2 in that scenario. So at here, as you can see, K equal to 2. I is area moment of inertia, and in this case the circle is, the cross section is circular. So go to the inside cover of the book, go down here, go down inside cover of the book. So here you go, moment inertia of common geometrical shape, and the circle one, and in this case IXS or IYY the same, it makes sense because circle, and it equal to 1/4 P R power 4, 1/4 pi R power 4, 1/4 pi over 4. So go back here, we can plug in the P Euler there equal to pi square E, what E equal to, for the 836 steel is 29,000 KSI. Go to appendix B as you have, and then I just show you it will be pi over 4 R power 4. So the diameter is 2, so it will be 1 inch power 4, and divide by K. You can see that is 2 times the length. In that case, the problem give us is 2 feet length, so 2 foot length. So that length here, the length of that one is L equal to 2 feet. So from that we can plug in 2 feet. As you can see, we use inch. KSI gives per square inch, so it have to be inch. So we plug in that one is 2, so it's 24 inches, and it have to be square in that equation. From that we will get P Euler critical load that called buckling. It equal to 97.6. 97.6 kips. What can we say? As you can see, the load is 100 kips. The water tank is 100 kips, 50 ton. The maximum, if it's not buckling, is 96.7 kips, which is less than the actual. This is the failure, less than the P actual. P actual, and P actual load here, as you can see, 100 kips or 50 ton. So from that, as you can see, this is the failure level or allowable, P allowable, and we also assume it factor of safety equal 1 is less than the actual. So as you can see, that one is not okay. Not okay, because the P actual have to be less than the P allowable, then it's okay for the structure, but in this case not okay. So in this time of bar, the failure is due to the buckling. So that the failure is due to buckling, as you can see, not crossing in here, because the actual of less than the failure due to buckle is 113 kips, but here failure due to buckling, the maximum, if it not buckle, is 97.6 kips. The actual is 100 kips. So in that case, as you can see, you can say that the bar fail due to buckling, right? Due to buckling, and in that case, we can see that is a long column. A long column. So that long, for the column that failed due to buckle, we call it long column. The column that failed due to crossing, that we call short column. For in these scenarios, let me see here. So when this become a short column, so what if, let me give you a what if. What if I have the actual load instead of 50 ton, I increase that into 100, let's see, 60 ton. What if P actual equal to 60 ton? So 60 ton is equal to 120 kips. 120 kips. And the L, the length of the bar, now it from 2, I reduce to only 2 feet. I reduce to 1.5 feet. 1.5 feet. So I make it shorter from 2 feet to 1.5 feet. So let's see that one here. You can say from 2 feet to 1.5 feet, and then the P actual from 50 ton go to 60 ton. So in that case, as you can see, the crossing is still not depends on the length, so the crossing it will not okay. So it equal to, as you can see, due to crossing, the P failure, it equal to 36 pi, the diameter unchanged, 2 square over 4, it's still 113 kips. So as you can see, crossing in that case, P for crossing, we have P actual equal to 120 kips less than P allowable, have to be, right? And in that case, P allowable 113 kips. Is that it less than or not? No. So GHE not okay. Not okay. Now, what if the failure is due to buckling? And in this case, we can plug in the P Euler. Okay, so P actual. Let's see the P Euler. In that case, what equal to? We can plug in there. It will be 5 square 29,000, which is the Young modulus of the steel time cross section and change. So 5 over 4, 1 inch power 4 divided by in that case, and condition still unchanged 2. But now the length, the actual length is reduced into 1.5 feet is from 2. So as you can see, that number is from 18 inches. So from that we have P Euler equal to 173 kips. 173 kips. So as you can see now, the P actual equal to 120 kips less than, in that case for the buckling, less than P Euler, which is failure due to buckling, and that is 173 kips, and that one is okay. So with that scenarios, if we increase the tank from 50 ton to 60 ton and reduce the bar length from 2 feet to 1.5 feet, and in this case the column will be fail due to crossing, not due to buckling, and in that scenarios we call that a long column. Sorry, it's a short column. That is a short column. So the column that failure due to a crossing, it is short column. The column due to buckling, it called it long column. And in the next 2 scenarios of the demonstration, I show you the failure due to buckling and the failure due to crossing with the water tank concept in this example. So keep that in mind when we start practicing the worksheet A to D.